Somebody you loved is gone. Doesn't matter when. Last week, last year, 40 years ago, when you were small, and you barely remember their voice, but you know, somehow, that it mattered. The room is empty. The chair is empty. The particular way they held a cup of coffee. The way they laughed at something stupid on television. The way they said your name when they were proud or annoyed or worried. All of that, you'd swear, just stopped. Vanished. Gone into nothing. I want to ask you something, and I want you to take it seriously. Where did they go? I don't mean spiritually. I'm not a priest. I'm a physicist. I want to know, literally, mechanically, in terms of the actual stuff that makes up the universe. Where did the matter go? Where did the energy go? Where did all the information that was them, the precise arrangement of every single atom that built that face and that voice and that mind, where did all of it go? Because in physics we have this stubborn, beautiful, almost impossible rule. Things do not disappear. They never have. Not once, in the entire history of the universe, has any physicist ever caught the universe deleting something. Not an atom, not a photon, not a single bit of information. The universe is, in some very deep sense, a hoarder. It throws nothing away. So if your grandmother is gone, and I'm sorry, but if she's gone, then where did she go? Because physics is telling me, in equation after equation, experiment after experiment, that she didn't go nowhere. That option is not on the table. So let's find her. Let's start with the easy answer. The one everyone gives. The one in the school books. The atoms. You're made of atoms. About 7 octillion of them, give or take. That's a 7 with 27 zeros after it. A staggering number. So staggering it ceases to mean anything. And those atoms, your grandmother's atoms, my atoms, they don't go anywhere when you die. They get redistributed. A body buried in the ground feeds the bacteria. The bacteria become part of plants. The plants get eaten by deer or cows or aphids. The carbon in your grandmother's eyes is right now almost certainly inside a tomato somewhere, or a crow, or a cloud of methane drifting over Iowa. The water that was in her tears is, statistically, now in a river or a thunderstorm or somebody's morning coffee in a city she never visited. The calcium that was in her bones is feeding a flower. The iron that carried oxygen through her arteries is, by now, probably scattered across half the continent, doing other jobs, in other bodies. And here's a number that should knock you sideways. With every breath you take, you inhale roughly 10 to the 22nd power molecules of air. That's a 1 followed by 22 zeros. And the atmosphere is well mixed. Has been for a very long time. So statistically, every breath you take contains atoms that were once breathed by Caesar, by the woman who painted the cave at Lascaux, by every person you ever loved. Right now, as you're listening to me, you have inside your lungs atoms that were inside your grandmother's lungs the day she was born, the day she fell in love, the day she said goodbye to you. You are, at this exact instant, breathing pieces of her, not in some woolly metaphorical way. Mechanically, atomically, the arithmetic forces it. The atoms persist. No question about it. We can prove this. We can measure it. The total mass of the planet doesn't drop by 1 milligram when somebody dies. The atoms just move. And this is the standard answer, and I want you to notice something. It's true, and it's also not enough. Because the question wasn't where did her atoms go? The question was, where did she go? Those are different questions. If I gave you a complete list of every atom in your grandmother on the day she died, every carbon, every nitrogen, every trace of zinc, and I told you, here, this molecule is now in a fish in the Pacific, and this one is in a tree in Kazakhstan, and this one is in your own bicep, would you say, oh, thank goodness, she's fine? You wouldn't. You'd say that's not her. That's just stuff. The stuff she was using. So the atom story is not the answer. It's a clue. We have to set it down and keep looking. Let me try something stranger. Every face is a transmitter. I don't mean metaphorically. I mean it physically. Light bounces off your face. Some of it gets absorbed by your skin, the rest reflects. The reflected photons leave your face, and they go in every direction. Some of them hit walls and windows and other faces. Some of them hit your retina and form an image in someone's brain, and that's how somebody sees you. But the rest, the photons that didn't hit anything, they just keep going. They don't stop. There's nothing to stop them. They go through the window, into the air, up through 10 kilometers of atmosphere, and out into space. And in space, with nothing to absorb them, they travel forever, at the speed of light, expanding outward in a sphere of photons. A sphere getting bigger every second by another 300,000 kilometers in every direction. Think about what that means. Every moment of every day of your grandmother's life, she was emitting and reflecting light. Photons left her face every second of her existence. Every smile, every frown, every time she turned her head when you called her name, light bounced off her in that exact configuration, carrying the exact pattern of her face in that exact moment. And a fraction of those photons escaped the planet and started traveling through space. Right now, as I'm speaking to you, the light from a moment in your grandmother's life, say a moment when she was 25 and laughing at something her sister said in 1968, that light is somewhere out there. It is, this very second, passing the orbit of some distant star, or threading through a cloud of gas in another galaxy, or flying through the empty dark, completely intact, carrying the exact pattern of her face in that moment, encoded in electromagnetic waves that no one has yet intercepted. If a sufficiently advanced telescope, sitting at the right point in space, were to intercept those photons, it would see her, not a memory of her, not a recreation of her. Her, the actual light from her actual face, 25 years old, laughing at her sister. This is not philosophy. This is just optics. And it is true of every face that was ever in sunlight. The light from every star you've ever seen, even ones that exploded 1,000 years ago, is still arriving somewhere. The light from the dinosaurs is hundreds of light years out. The light from the first humans who looked up at a moon is on its way past stars whose names we have not yet thought to give. The universe is a permanent record of itself, a permanent, glowing, expanding record written in light. Most of that record is unrecoverable. We will never build a telescope. We will never sit at the right point in space. The information is, for any practical purpose, beyond us. But practical purposes are not the same as physical reality. The light is there. The face is there. It is real, it is propagating, and it is permanent. And again, I want you to notice something. This is true. This is wonderful. This gives me chills when I think about it. But it's still not her. It's a picture of her. A very real, very physical, very persistent picture, traveling at the speed of light through the cosmos. But a picture of someone is not the someone. So we have two clues now. The atoms persist, but they're not her. The light persists, but it's only an image. We have to keep going. Let me ask you a stranger question. What is a person, really? At the deepest physical level, what makes you you? It's not your atoms. We replace those constantly. The atoms in your body now are mostly different from the atoms that were in you 7 years ago. If you're 40, you've already been completely replaced, atom by atom, about 5 times over. So if it were the atoms, you wouldn't be you anymore. You'd be a different person every few years. But you're not. You're the same person. Same memories. Same personality. Same weird laugh. So what is the same? The pattern, the arrangement, the information about how the atoms are arranged, how they move, how they connect, how they fire signals to each other. The whole structure of you, the wiring of your brain, the shape of your face, the rhythm of your heart, is information, a specific pattern. And when one atom gets replaced by another, the pattern keeps going. The pattern is what's continuous. You are, in the most rigorous physical sense, a pattern of information that uses atoms the way a song uses radio waves. A song does not live inside a particular set of radio waves. The waves carry it. The song could be carried by other waves. The song is the pattern, and the pattern is what we call the song. You are like that. Your grandmother is like that. And here is where it gets interesting. Because in physics we have this principle, and it's not a small one, it's one of the deepest principles we know, that information is conserved. Information is never destroyed. I want you to be careful here. This is going to sound like I'm saying something I'm not. I'm not saying your grandmother's information is sitting in a vault somewhere, ready to be downloaded. I'm not saying that at all. What I'm saying is much weirder and much more interesting. In quantum mechanics, the equations that describe how the universe evolves are what we call unitary. That's a mathematical word. What it means in plain English is this. If you knew the exact state of the universe at one moment, you could in principle calculate the exact state at any other moment, past or future. The universe doesn't lose information. It just rearranges it. It scrambles it. It hides it. But it does not delete it. Stephen Hawking in 1976 did a calculation that bothered everyone, including me. He showed that black holes radiate. We call this Hawking radiation. He showed that this radiation appears to be essentially random thermal noise with no memory of what fell into the black hole. And if that were really true, then black holes would be the universe's deletion machines. They would be the one place where information actually goes to die. This calculation, when it came out, started one of the great arguments in modern physics, an argument that is still going on. Because if information could be destroyed, even just inside black holes, then the equations of quantum mechanics, the equations we have checked to phenomenal precision in countless experiments, would be wrong in a fundamental way. Either Hawking was wrong or quantum mechanics was, and those were not easy options to choose between. I will tell you what most of us, working on the problem, believe. We believe quantum mechanics. We believe information is conserved. We believe the radiation only looks random, that hidden inside it, in subtle correlations no one can yet read, the information about what fell in is preserved, scrambled almost beyond recognition, but mathematically intact. We do not yet have a complete proof. We may not have one for a long time. But the universe, we suspect, still does not have a delete key, not even at the bottom of a black hole. That is how seriously physics takes this rule. So the information about your grandmother, every detail, every neuron firing pattern, every memory she ever had stored in her brain, every word she ever said, every dream she ever had, every fleeting embarrassment she felt at 13 years old, the precise way the muscles in her face arranged themselves when she laughed. In principle, that information is still in the universe. It has been scrambled. It is mixed in with everything else. It is distributed across the photons her brain emitted, the heat her body released, the molecules of air that left her lungs in every breath, the microbes that disassembled her body, the warmth that radiated from her skin into the room she lived in, the slight gravitational tug she gave to the moon and the planets while she was alive. You can't reassemble it. Nobody could. Not all the computers in the world, working since the beginning of time, could put your grandmother back together from that scrambled signal in any reasonable amount of time. The information is, for all practical purposes, gone. But for all impractical purposes, the universe is keeping it. The universe didn't erase her. Nothing has the authority to erase her. Not the laws of physics, not entropy, not the heat death itself. She's distributed. She's scrambled. She's beyond reach, but she's not gone. Now I want to give you the strangest clue, the one that took physicists a long time to swallow, the one I'm not going to tell you to believe, only to consider. It comes from Einstein. When Einstein figured out relativity, and he did this twice, once in 1905 for special relativity, and again in 1915 for the general one, he proved something we still haven't fully come to terms with. He proved that time is not what we thought it was. You think time flows. You think there's a present moment, and the past is behind you, gone, and the future is ahead of you, not yet existing. You think now is special, universal, the same for everybody. It isn't. Einstein showed, And we have checked this with atomic clocks on airplanes, with satellites in orbit, with particles in accelerators, in thousands of experiments, and it always works out the same way. That now depends on how fast you're moving. Two people moving differently disagree about which events happen at the same time. There is no master clock. There is no universal present moment. Let me give you the experiment that nailed it. There are particles called muons. They are unstable. In the laboratory, when they sit still, a muon lives for about 2 microseconds and then decays. 2/millionths of a second. But muons are also created in the upper atmosphere when cosmic rays hit air molecules. They form about 10 kilometers up, now traveling at nearly the speed of light. Even if they didn't decay at all, they would only have time to fall about 600 meters before 2 microseconds was up. They should never reach the ground. But they do reach the ground. We measure them all the time. They show up at sea level by the millions every second. Why? Because of relativity. From the muon's point of view, traveling near the speed of light, time is running so much slower for it than for us, that the trip down to the ground takes only a tiny fraction of 2 microseconds. From our point of view, the muon's clock is dilated, stretched, almost frozen, so it has plenty of time to make the journey. Both pictures are correct. There is no fact of the matter about which picture is the real one. The muon's now is different from your now, and there is no master frame to refer back to. That is what Einstein proved, and it has consequences. Because if there is no universal present moment, then in a very real sense, the past is not behind you. It is just somewhere else. Picture it this way. Imagine a loaf of bread, the whole loaf, sitting there. If you slice it one way, you get one set of slices. If you slice it at an angle, you get different slices. But the loaf is the same loaf. All the bread is there. Every slice is real. Every slice exists. Spacetime is like that loaf. The whole thing, past, present, future, is one big 4-dimensional object. We call it the block universe. And we, conscious beings stuck inside it, slice through it one moment at a time, and we call the slice we're currently in now. But the other slices don't cease to exist when we leave them. They are still part of the loaf, still in the universe, still real. If this is true, and a great many physicists, after struggling with it for 100 years, have grudgingly accepted that it might be, then your grandmother in 1968, 25 years old, laughing at her sister, is still there. Not as a ghost, not as a memory, as a real physical event in space-time, permanently embedded in the structure of reality. You can't visit her. You can't reach her. There is no telephone line back through time. But she has not been deleted. Time didn't erase her. Time can't erase anything. Time is just the dimension we're traveling through. I want to be careful. Not every physicist accepts the block universe. Some prefer interpretations where the future is genuinely open, where now really is special. This is unsettled. We do not know which is right. But what I'm telling you is that the block universe is taken extremely seriously by people who know more about time than you or I will ever know. It is not weirdness. It is a respectable answer to the question of what time is. And in that answer, your grandmother didn't end. She stopped being adjacent to your slice. That is not the same thing as ending. So let me bring all the clues together. We started with the question, where did she go? And we found 4 answers. None of them, by themselves, are satisfying. But all of them together, they tell us something we did not expect. The atoms went into the world. They are now part of trees and stones and other people and the air you are breathing right at this moment. There is statistically at least one atom currently inside your body that was once inside hers. Your bodies were never quite as separate as you thought. The light from every moment of her life is racing outward through the cosmos. A permanent expanding record, traveling in every direction at 300,000 kilometers per second, and it will keep going for as long as the universe lasts. The face she had at 20, the face she had at 50, the face she had at the moment she said goodbye, all of it is still propagating, still real, still encoded in the electromagnetic field, somewhere out in the dark. The information that was her, the precise pattern, the structure, the shape of her, is preserved in the quantum state of the universe, scrambled but conserved, because the universe does not have a delete key. The universe is, in the most literal sense possible, incapable of forgetting. And the moments she lived through every Sunday morning, every joke, every kiss, every disappointment, every quiet evening on the porch when the cicadas started up and the light went orange, are permanently embedded in the four-dimensional structure of space-time, as real today as the moment they happened, as real tomorrow as they were 1,000 years ago. What does that add up to? Here is what it doesn't add up to. It does not add up to a soul floating around watching you. It does not add up to her hearing you when you talk to her photograph. It does not add up to a reunion in heaven. I am a physicist. I cannot tell you about any of that. I do not know what I do not know. There may be more to the universe than physics has yet found. There almost certainly is. But the things I am telling you tonight are not those things. The things I am telling you are equation and experiment certain, or as close to certain as any of us ever get. And here is what it does add up to. The universe, the actual physical universe, the one you live in, the one made of atoms and light and information and time, that universe does not throw anything away. The picture you have in your head of death as deletion, of the dead as nothing, that picture is wrong. It is provably, demonstrably, equation by equation wrong. You inherited that picture from somewhere, from movies, from common sense, from grief itself. But it is not how the universe actually works. The universe is a record, a permanent, distributed, unspeakably beautiful record. Every face that was ever lit by sunlight is still glowing somewhere out in the dark. Every atom that ever made up a person is still in the world, doing other jobs, holding up other bodies, drifting in other clouds, sitting at the bottom of other oceans. Every moment that ever happened is still part of space-time, fixed there forever, by the same physics that holds the planets in orbit and lights the sun. The people you lost are not stored where you can reach them. I want to be honest with you about that. You cannot call them back. You cannot reconstruct them. You cannot ask them for advice. And the absence in your house, the empty chair, the silence at dinner, those are real, and physics will not fill them. I would be lying if I told you it could, but the universe has not erased them. That is a different claim, and it happens to be true. We tend to imagine a person's life as a candle. It burns, it flickers, it goes out, and then there's nothing. Just a thread of smoke, dispersing, until even the smoke is gone, and then absolute, total, completed nothing. That is not the picture physics gives us. Physics gives us a different picture. A person's life is not a candle. It is more like a stone dropped into a pond. The stone goes down to the bottom and rests there. Sure, that is the body. That is the burial. But the ripples spread outward. They keep spreading. They never stop spreading. They go to the edges of the pond and they keep going, into other ponds, into the air, into the soil, into the photons emitted by the surface of the water, into the warmth that the sun and the stone exchanged on a Tuesday afternoon in 1971. The stone rests, but the universe is full of the consequences of the stone. That is what a person is, a stone, and the ripples, forever the ripples. When I lost my first wife, Arline, in 1945, she was very young. We both were. She had been sick for a long time. I sat with her at the end. I held her hand when her breathing stopped. I knew, with the kind of clarity grief gives you, exactly how complete the loss was. About 1.5 years after she died, I wrote her a letter. I addressed it to her. I told her I loved her. I told her I had been thinking about her. I told her she was still my wife, and I was still her husband. And then I added a small note at the end, almost as a joke, asking her to please excuse the fact that I was not going to mail it, because I did not have her new address. I did not believe she was reading it. I am a physicist. I do not believe in things I cannot measure. But I think now, looking back, that I was telling a kind of truth I did not fully understand at the time, because she was, and is, permanently woven into the structure of the universe I live in. The light from her face is still racing outward through space. The atoms that made her are still here, scattered, doing their jobs. The pattern of her, scrambled across the quantum state of everything she ever touched, has not been deleted. And the moments we shared, in 1941 and 42 and 43 and 44, are still part of the four-dimensional loaf of spacetime, real and unalterable and permanent. She was, and in physics, was is a kind of is. So when you think about the people you have lost, your mother, your father, your friend, your child, your dog, your old self at 23 before life broke you a few times, I want you to consider that the universe disagrees with your grief, not your love. Your love is right. Your grief is right too, in its way. There is no remedy for the empty chair. But the part of your grief that whispers they are nothing now, that part the universe will not back up. Nothing is the one thing they cannot be. They are scattered. They are encoded. They are radiating outward at the speed of light. They are permanently embedded in the geometry of time. They are everything except gone. And you, the small, breathing, briefly conscious slice of spacetime called you, you are doing the same thing right at this moment. The light from your face today is escaping the atmosphere. The information of your day is being scrambled into the quantum state of the universe. The moment you are living, right now, listening to me, is being permanently embedded in the structure of spacetime as I speak. 100 billion years from now, when the last star has gone out, the moment you are in tonight will still be a moment that happened, still real, still woven in, still part of the loaf. You will not vanish either. None of us will. That is not how the universe works. That has never been how the universe works. I do not know if any of that helps. I do not know if it fills the empty chair. I doubt it does. Physics is not a comfort that competes with arms around your shoulder or a familiar voice on the telephone. But I think there is something to be said for knowing how the universe actually behaves. For knowing that the picture in your head, the picture of total deletion, is wrong. That nature, the actual nature you and I and everyone else live inside of, is not in the business of erasing things. It is in the business of keeping them, in scrambled and inaccessible and stubbornly beautiful ways, forever. So if there is somebody you are missing tonight, I want to ask you something. What did the light from their face look like? What was the moment of them you wish were still close enough to touch? The universe still has it. I promise you, it is just farther away than your hands can reach.